Hi, hello everyone. Welcome to Tariga Engineering Solutions. We accompany you in your civil engineering journey. Today, we'll be discussing fluid mechanics. Most importantly, specifically, it would be properties of fluids. So in this video, we'll be discussing regarding about the density, the unit weight, the specific gravity, the specific volume of such it is relative to fluid mechanics. So this will be the first part of the video series of the fluid mechanics. So without any further ado, let's start explaining and let's start learning the principles and the formulas we need to learn for future references. Let's start. Okay, the first property of fluid is called the mass density. Well, what is a mass density? We've been hearing this since when we are elementary, okay? But it is very vague what is a density because but most of the time the formula is the same. Yes, the same lang talaga. So the definition of that, the mass density represents the mass or the number of particles per unit volume of a substance, material, or object. The denotation of mass density, most of the books, the references that we had here in the Philippines, they denote mass density as rho, Greek letter rho. Okay, so the formula for the mass density is the ratio of the mass over volume. So it is very clear naman from the definition itself, representing the mass per unit volume. So therefore, that would be the ratio of mass over volume. The denotation here in our lecture series, mass is small m and the volume is capital V. So that's it. The formulas, or no, not the formulas, the units of the mass density are kilogram per cubic meter in SI or slug per cubic foot in English unit. So that would be the units that is under, no, or that is the unit for the density. Next, specific volume. What is a specific volume? It is defined as the number of cubic meters occupied by 1 kilogram of matter. It is the ratio of material's volume to its mass, which is the same as the reciprocal of its density. So it is very self-explanatory yung definition. No? Number of cubic meters occupied by 1 kilogram of matter. So that will be the reciprocal of this. Okay, so we will denote that as V sub S, specific volume. So that would be volume over mass, or just the reciprocal of the density, 1 over rho. So it is very clear that the unit of the specific volume would be the reciprocal of these. So that would be cubic meter per kilogram, or in English, cubic feet per slug. Okay? So kana siya. Next, unit weight or the specific weight denoted as gamma. So the unit or the specific weight of a substance is the weight of unit volume of the substance. For liquids, it may be taken as constant for practical changes of pressure. So most of the time, from fluid mechanics, hydraulics, geotechnical engineering, we will be using unit weight. Okay, unit weight. That would be very, what do you call that? It is very useful here in the Philippines, no? Sa study natin sa subjects na yon na I mentioned. So the difference between the density and the unit weight is just the units lang. No, the units, or sort of specifically yung unit weight kasi, that is relative to the weight of the molecule or the part of the matter. While the density is yung mass lang of the particle or matter. So the formula to that would be the ratio of the weight over volume. And unit is, okay, before the unit, you may also calculate the unit weight by using this formula, rho times g, where g is the acceleration due to gravity. Okay, so again, the unit to that is kilonewton per cubic meter or newton per cubic meter. Next would be the specific gravity. The specific gravity of a body is the dimensionless ratio of the weight of the body to the weight of an equal volume of a substance taken as a standard. So based on the definition, mathematically expressed, specific gravity is the weight over the weight standard. Okay, but I know this is not familiar to you. Ganito kasi yan. No. The weight, a ratio of the weight body to the weight of an equal volume. Siyempre, we cannot just calculate the weight of any solid or liquid or any matter without a volume, right? So how do you measure weight without a volume? So therefore, in order to be safe, mas madali yung pag-analyze natin. We'll be using the ratio of the density or the ratio of the unit weight. In that sense, provided that they have the same volume, we assume that they have always the same volume, it can be cancelled. So that is the same as the ratio of the weight also. Okay, there is a universal, what do you call that? Universal standard for this specific gravity. For solid and liquid, the basis of all the specific gravity is always the water. So for the density and unit weight of water, ito yan, no? Unit weight of water is 9.81 kilonewton per cubic meter. That is in SI unit. Or in English unit, that is 62.4 pound per cubic foot, right? So 62.4 pound per cubic foot. And for the density, it could be 1,000 kilogram per cubic meter. So these values are very important. So memorize ni siya. Kindly memorize if you don't memorize it yet. But careful, these numbers or figures that you see is only applicable for 4 degrees Celsius. What does it mean? So during experiment, this unit weight or these values was observed at 4 degrees Celsius of a temperature. So how about if another yung temperature? Well, usually ito talaga yung ginagamit at 4 degrees Celsius. Maybe if hindi siya stated or not, usually ito yung ginagamit natin. But there is another at 20 degrees Celsius, 9.79 siya. No? And still 62.4 and 998 na siya. So this is at 20 degrees Celsius. Okay, so meron lang siyang konting difference. But anyway, most of the times ito lang talaga, no? Ginagamit natin. Well, if you can observe, if the answer is medyo malayo sa nakuha mong sagot, maybe they use the 20 degrees Celsius na mga figures or the numbers, no? Not this one. Okay, so just memorize na lang all of those. Okay, so for gases naman, the unit weight of air is approximately 11.8 Newton per cubic meter, or for English, unit that would be 0.0752 pound per cubic foot. Okay, so now we are done sa principles and the formulas natin. Let's apply to these examples. Example number 1. A reservoir of glycerin has a mass of 1,540 kilogram and a volume of 0.895 cubic meter. The questions are, find the glycerin's weight, the mass density, the specific weight, and the specific gravity of the glycerin. So first, number 1, for the glycerin weight. So how do we calculate for the weight? if given yung mass and volume? Well, for this part, sa number 1, we won't use the volume, yung mass lang, no? So, ito yung given. Kasi, ang weight is the product of the mass times the acceleration due to gravity. Okay? Mass times gravity. Again, where G is acceleration due to gravity. So 9.81 na siya meter per second squared. Or if you're familiar with, sa English unit naman, that would be, isulat ko na lang dito, 32.2 feet per second squared. Kana siya. Okay? So anyway, any of those pwede. Basta, if SI, 9.81, if English, 32.2. Let's continue. So the mass is 1,540 kilogram times 9.81. So we will get what? Okay, we will get a value, but wait, unahin na lang natin yung unit. Kilogram meter per second squared is equal to 1 Newton. So yung value magiging 1,540 times 9.81, that would be 15,107.4 Newton. But sad to say, this is not yet the final answer because the question is specified na dapat in kilonewton. So remember, multiply muna natin yan, 1 kilonewton over 1,000 Newton. This is a conversion factor. So by simplifying, the weight is equal to 15.11 kilonewton. Okay, let's move on to number 2. Find the mass density in kilogram per cubic meter. So the formula to mass density based sa na-discuss natin kanina is the ratio of the mass over volume. So just substitute 1,540 kilogram over 0.895 cubic meter. So the density shall be 1,720.67 kilogram per cubic meter. Okay? Next, number 3, the specific weight. For the specific weight, we have the formula of weight over volume. So luckily, we got the weight kanina, that is 15.11 kilonewton. So i-divide na lang natin yan for, by the volume, 0.895. So that would be equal to 16.88 kilonewton per cubic meter. Or pwede natin gamitin yung other relationship, no? The specific weight is equal to the product of the density times the gravity. Okay? So gamitin natin to. Okay, so that would be 1,720.67 times 9.81. It will become 16,879.77. So let me check for the values, no? If tama ba talaga? 1,720.67 times 9.81. Yes, it is correct. Okay, so we are not done yet because what is asked is in kilonewton per cubic meter. So we convert natin yung Newton into kilonewton by having the conversion factor 1 kilonewton divided by 1,000 Newton. So that will be simplified into 16.88. So as you could see, equal talaga yan. Kine and kana. Okay, let me encircle na lang all of the answers. Okay. Last part, number 4. Find the specific gravity. So the specific gravity has the ratio of this unit weight of the glycerine over density of glycerine over density of water. So you may use this one. I use the unit weight, no? 16.88 over 9.81. So cancel yung unit. The specific gravity shall be 1.72 yung specific gravity. Or you may use the other, no? Ito, unit weight mo na siya. Let's try density. So yung density is 1,720. 0.67. Remember that the unit weight or the density of water is 1,000. So that would be 1.72. Tama pa rin. Okay? Next problem. The volume of a rock is found to be 0.00015 cubic meter. So if the rock specific gravity is 2.6, what is its weight? So ganito lang. Okay? The solution, syempre we will first solve for the unit weight of the rock, syempre, no? How do we do that? Dadaan tayo dito, no? Specific gravity of the rock. So specific gravity is unit weight over the unit weight of water. So if we will apply that to the rock, that will become like this. No? Cross multiply lang yung specific gravity and the unit weight of water. So by using this relationship, that will give us 2.6 unit less yan because that is specific gravity times 9.81, that will give you 25.506. Okay, so we're not done yet. We will get the weight. So remember that the unit weight is equal to the weight over the volume, which is we have the volume already. So transpose the terms, that will give you this relationship also. So by using this formula, that will give us 25.506 times 0.00015, and the weight of the rock shall be equal to 3.83 times 10 to the power of negative 3 kilonewton. So the problem did not state whether it is kilonewton or newton, so we could say this is the answer, but in order for us to have a much significant figure, no, mas magandang tignan, let's convert this into Newton. So that would be 3.83 newtons. So that is the answer. Okay? Eto. So then, next problem. If an oil, which is the specific gravity is 0.8, is in a container whose dimensions are 3 meters by 2 meters by 1 meter, calculate the following. So number 1, the volume of the container. Number 2, unit weight of the oil. Number 3, the mass density. And number 4 is the mass of the oil. So number 1 is the easiest because we learned in mathematics, no, the volume of a container, or suppose having 3 sides, volume is just length times width times the height, or that is the volume of a sort parallelepiped, no, or a cube, or sort of prism, pwede ganyan, area of the base times height. So the volume of the container shall be equal to 3 times 2 times 1, so that will become 6 cubic meter. So ito na yung sagot sa number 1. Number 2, unit weight of the oil. So we will use the previous solution in order to get the unit weight. Dadaan tayo sa specific gravity. So part 2, that will be this relationship. So the unit weight of oil can be calculated if we will multiply the specific gravity to the unit weight of water. So by that, substitute the values, specific gravity 0.8 and 9.81. So the unit weight of oil is 7.85 kilonewton per cubic meter. So part 3, mass density. So pwede natin gamitin to. We will use this, having the relationship of unit weight is equal to density times the gravity. So rearrange lang natin, that will give us this relationship. Substitute all of the values. Unit weight is 7.85 and G is, syempre, this is still as a unit, so that would be 9.81 meter per second squared. So in this one. Okay, but let me remind you, no, be careful. That would be kilonewton pa man siya. So we need to convert that into Newton first before we can proceed to the density. So para ma-cancel yung kilonewton, multiply ito ng 1,000. Cancel yung Newton, so Newton per cubic meter. So 9.81 meter per second squared. So the density of oil shall be 800.2 kilogram per cubic meter. Yun. Gana. And for part 4, mass of the oil, obviously we will be using the density of the oil from part 3. So that will become this one. Okay, density of oil is equals to mass of the oil over V. So that will be ganito, 800.2 times 6. So the mass of the oil is 4,801.2 kilogram. All right. So that's it for this first part of the video. So if you like what you see, no, if you like the video, please click the like button. And for more videos to come, click on the notification bell for you to be what you call that notified no when we have a new video, and don't forget to subscribe na lang din. So thank you for watching and have a great day everyone. Thank you.